Aris, Ibrahim, Al-Ghamdi, Ibrahim Al-Ghamdi, Manner, Faisal Al-Qadi, Wafa, Raza Al-Ghatani, Hatem, Faisal, Abdulrahman. How about Yu Hang Kao, Yan Chen, and Banging Deng, Abu Bakr Fadi, Tian Shu Bao, Zhu Li, Ziyuan Li, Heng Yuan, Mohammed Mehdi, Didier, Mohammed Mehdi, okay. Lei Ning, Nui Ti Nui, Sibo Chu, Bei Xiang Ran, Hui Wang, Ya Wei Yan, Chao Ying, Jun Zi Zhang, Chao Ying, Walid, Yishan, Wen Hui, Hu, Sidi Son, Kalaya, Hua Feng, Huang Feng Wang. You?
Yeah.
Okay. But you answered the Yahweh one, right? Who's the Yahweh one? Yeah.
Yahweh Yang.
Hui one. You answered the Hui one, right? Very different. Anyway. Xing Rui Wu. Okay, so we are talking about first, as I mentioned several times, so this is the first semester after I changed the curriculum. So I'd like to cover the advanced topics of the database in this class in advanced database design. And then CPS 450 will cover the fundamental of the database design. Usually it's for the the undergraduate computer science or the computer engineering major or the non-computer science student supposed to take the CPS 450. Then this is CPS 450 should be prerequisite of the 551 advanced database design. Unfortunately, this semester I cannot offer the two courses separately. Instead, it's cross-listed, which means I have the several undergraduate students or a bunch of the graduate students, even the PhD student I hear. I know this is not usual. In one class there are 3 different degrees, so it's very hard to satisfy all the students, but I will try to my best to cover from the beginning to all the advanced topics. So that's the reason I little bit speed up. I guess it's almost 2 times faster than the CPS 450. For undergraduate student, it will be a little bit tough. Even the graduate student who never took the database course will be a little bit hard. So you are responsible to catch up. I will consider only the undergraduate student when I decide the final grade. But for the graduate student, no matter where you are, it's a non-computer science student or the master PhD student, it will be considered uniformly, equally. Okay, so you need to catch up. I'm not sure how many students will fail this course, but probably some of them. So, but if you follow my direction and my guide, definitely you can pass successfully finish this course. Right now we are discussing about so far we are designing the database from the information. We have the bunch of information in your real life, so you have a lot of information you collect, and also you, whether or not you realize you have a bunch of the information. However, you don't want to keep track of all such information. Only some meaningful information will be collected and will be managed in the database. That is the data. So first thing you need to do when you build a database, a system database design, you need to find which information will be managed, stored at the database. That is the conceptual modeling, conceptual design. That doesn't require any computer science skill. Instead, you need a lot of the domain knowledge. So using that domain knowledge, you can collect, you can decide some meaningful information to build a very fancy, nice the diagram. Sometimes it can be, for example, using the ER model, you can build the ER diagram. So using that ER diagram, you understand what will be the meaningful information, eventually which data will be stored and managed in the database. That is a conceptual design. Also, we learn database modeling, especially the relational database model. So this is the information in human being, real life, but he is the computer. So our goal is to build a database system on the computer. But as I said, the computer is not smarter than you. So computer can understand only structured information, structured data. So for that structure, we learn relational database model. What is a model? What is a model? It's a bunch of concepts that define the data structure. So especially we use relational database model. Relational database model is based on what? It's a mathematical model. It's a set theory. So we consider group of the data as a set. Then we can utilize a bunch of the nice, efficient set operation, mathematical operation to access, to manage the data. That is a relational database. So we have the conceptual design. We have the relational model. However, computer cannot understand your concept. Computer can understand easily the relational model because the main objective of the relational model is for building database on computer, right? However, conceptual model, ER modeling, ER diagram, it's not for computer, it's for human being. You can understand easily the information that you are going to manage. So we need to bridge the gap between conceptual design and relational model. In other words, can we convert the conceptual design into relational model? For example, can we change it? Can we map the entity that you design in ER model, in conceptual model to relational model? Then finally, computer can understand what you are thinking, what you are building. Okay, our goal is not the imaginary thing or the creative idea, just the database on a computer. Okay, so we need to convert such a conceptual model into the data structure. That is the main goal of this course, database design. Okay, so last time we have learned about the step. So our goal is from the ER model to make the relational schema diagram. Then it's not a big deal to create the database about this schema diagram using DBMS software. Then that will be covered in the structured query language course. Okay, especially with the exercise lab, because you should be able to create. Basically, you understand the relational database, but if you cannot create the database using software, no, nothing. So you will learn how to create using the SQL to the database based on this one. But still we didn't complete how to convert this one to this one. Okay? So we learned about some basic steps, step 1 through step 10. So step 1 and 2 is for what? Entity. So we have the bunch of entity here. Entity can be mapped to relation and several foreign key. And also some associated the attribute. Attribute will be column in relational model, something like that. Also, we have 3 different types of the relationship. Relationship, depending on the types of the cardinality of the relationship, it can be sometimes a relation, or sometimes a table, sometimes just a foreign key, sometimes merge, sometimes the in-between new table will be created. I know if you are considering simple database model, simple conceptual design, even though you do not know this step, it's easy to create the table, just like as you did in the program language class. So you create several tables. At that time, it's very hard to say that is a database system. That is just to use the extended data storage instead of the programming. As we discussed the first class of this class, without database, yes, you can be survived. You can live. You can make the program application without DBMS system. Think about your laptop. Does your laptop include the Oracle database to manage your data? No, you never use such a thing. This is only for special case. Special case means very large data when you have. So at the time you need. So program, sometimes for your practice you can create the database, but at the time it's simple. So you may not realize this step. But in case you have the 2,000 entity, 2,000 table, it's very hard to directly create the database. Even sometimes you lose some important constraint. So we will follow such a step, especially for step 6 and step 7. Step 6, if you are using object-oriented database or the object-oriented model, you don't have to worry about such a multi-valued one. However, according to the relational model allow only atomic data. Atomic data means it cannot be divided. Okay? It cannot, in other words, it cannot handle multi-value. So when you describe the Professor Lee, so Professor Lee wear the several clothes, there are several colors. So property of the color of the Professor Lee is the black and the brown and whatever. That is possible. However, in relational model, only one value for each attribute. So how can we describe such a multi-valued, multi-colors in the database? At the time, we need to create the new relation to handle such a multi-valued ones. That because of this reason, actually when you create the real database system, that database system has usually, most of the case, much more tables than you expected. Some of them are just, it's called a code table, or sometimes the legend table, it never changes. So 1 is HR, 2 is something, 3 is something, or the cross list table. So that is the reason usually you have the much more the tables you have than you expected. The other 2 steps is for EER concept. What is the EER concept? Extended?
Entity relationship.
So ER modeling is a very nice tool to design, to model the information. So it can be used in many applications, including database. It can be used for the directly software engineering. It can be used for some other thing. But it's limited, very strict. Even though that is easy to learn, but it's a very strict rule. It cannot represent all the relationship in real life. For example, super and subclasses. So I gave you the example of the specialization or generalization, which is a common process of training. So when you learn the concept, when you learn the language, when you learn the, I gave the example of the apple. So when I learned the language. My mom explained this is the apple, this is another apple. Then I can eventually make my own concept of the apple. Then when I see the apple in the grocery store, I never seen that apple, but I know that is the apple. That is a specialization. It's a generalization and specialization process with the training. It's the same thing in the database. You can see, you can encounter a lot of such a super and subclasses relationship. It's not a big deal when you are using object-oriented concept. You can create the object, then you can reuse. That's it. However, relational model cannot handle such a super and subclasses relationship. So, how can we convert to such a thing? So, there are 4 options to handle super and subclasses relationship. First one is option 1 is, why don't we create a relation table for each class? For example, so when this is one of the example of the super and subclasses. So for example, employee and technician and secretary, engineer. Can you remember that? Okay, this is a basic first example of the super and sub extended ER diagram. Okay, it can be disjoint, it can be overlap. I do not specify that one, but this is a super and subclass. Option 1 is, why don't we create the relation for each class? So this is an employee. This is technician. And this is the secretary. This is the engineer. Okay? Then, what is the key of employee? Primary key. Each relation must have primary key. Okay, that is the rule, that is the constraint when we learn the relational model. So, this one will be, for example, social security number. Then all other attributes. What about technician? Technician, actually it was the subclass of the employee. But when we create the database using relational model, we will consider technician as a one table, one relation. So technician, what will be the key, primary key of this one? SSN, because you can inherit all the information about this. At that time, technician have the technician grade, like this one. Do I need to create the attribute of all employee? Because you inherit. Do I need? You don't have to. Instead, you can create foreign key to social security number. Which means, whenever you need more information about the technician, you can use foreign key constraint, then find the employee information. Then you don't have to make the duplicated information. Similarly, secretary, social security number, and attribute of this one, then create foreign key. And engineer is the same thing, like this. This is the first option. First option, you can create one relation, one table for each class. Okay, then create foreign key. That is the first option. Second option is, why don't we create one table for each subclass only? Technician, secretary, engineer. Then primary key of each relation, each table is social security number. No problem. However, what about attribute of superclass employee, like the DOB or address? We do not have the employee table in second option. We need to inherit all information about superclass to each subclass. Okay, so that means DOB and address and so on. DOB address, DOB address. It looks like the duplicate, but not duplication actually. It's the duplicate of the name only. Data will be stored for each corresponding table. This is the second option. Okay, so let's take a look at the real example. What about the foreign key? Do I need to create the foreign key? No. They are separated employee. Technician employee, secretary employee, engineering employee. So they do not share the information. You don't have to create the foreign key. So this is the example of the employee. So why don't you bring the any scratch paper, then convert this one into option 1. It's not the exam, just for your practice. I will give a couple of minutes to convert this. How many entities do we have here? One entity. It's for employee. It's a super and subclasses. It doesn't matter whether this is a disjoint or overlap when you convert into the relational model. Relational model doesn't care the disjoint or overlap. So, in first option, how many table, how many relation? 4. 4 of them. Okay, why don't you draw the relational diagram? Then first thing is find primary key of each relation. Then create the attribute column name for each relation. Then if needed, create the foreign key from 2. If you are done, then why don't you apply the second option? Second option is only for this. So how many tables?
3.
3 tables you need. Then find the primary key as well as the attribute. At that time, be careful. You need to inherit all attributes of the superclass for each subclass. Let's solve the problem together. So option 1. So how many relations do we need? 4 of them. First one is for employee. So this is for employee. So what will be the key of primary key of the employee? It's a social security number. Then underline, should be underlined using the relational schema diagram. So name. Can we handle the name as the composite attribute? No. Relational database model cannot handle. You can select either one name attribute or first name, middle name, initial, last name. So first name, middle name, initial, last name. Then first DOB and address, job time. The next, secretary. What is the key of secretary? It's SSN. Okay. Then what will be the attribute of the
Typing speed.
It's the typing speed. What about first name? You don't have to create the attribute of the secretary for the name. Instead, you can create a foreign key. Then, or it's the same as the inheritance. That's it. What about the technician? It's the same thing. Social security number and T grade. And create this one. And others. Engineer. Social security number and engineer type. That's it. That's the first option. Second option, you can convert. Then eventually you will create the 4 tables here. Second option is only for subclasses, which means secretary. What is the primary key? Social security number, SSN, and what? Definitely typing speed. Then whole attribute of the employee. First name, middle name initial, last name, DOB, address, and job type. What about technician? It's the same thing. It has social security number, T grade, and first name, middle name initial, last name, DOB, address, and job type. Do we need to create the foreign key? No, they are separated. Okay? And engineer, it's the same thing. SSN, engineer type, ENG type, then it's the same thing. Okay, that's it. That's the second option. Third option is, there are 2 more. Option 2. Option 3 is, why don't we create one big table for employee only? Because how many entities do we have? It's a one entity for what? Employee. So we can create the employee. Okay? Social security number as the primary key, and first name, last name, middle name initial, last name, and DOB, address, job time. Then we need to handle subclasses. So this time, each employee may be secretary, maybe technician, maybe engineer. So who will ask whether this is the secretary or not using Boolean type. You know the Boolean, yes or no. So ask yes or no. If yes, this is yes or no. Then what is the attribute of this one? Typing speed. If this employee is not secretary, this one will be null data. Otherwise, insert the typing speed. Similarly, technician. Technician, yes or no. This is a Boolean type. Then T grade. In case technician, you can insert T grade, technician grade. Similarly, engineer type. Engineer, yes or no? YN. Then ENG type. Then you can handle it. This time you don't need job type. Okay? Why? Job type will be handled yes or no for each job type. Okay? So this is the third option. The last option is, it's so similar as this one. One employee table. Then social security number. First name, middle name initial, last name, DOB, address. This time ask job type. What is type of job? Okay? Type of job is either secretary, either technician, or engineer. Okay? Job type. Then put the attribute of subclasses. That is the typing speed and T grade, engineer type. What's the difference between option 3 and option 4? What's the difference? So, bonus point if you answer correctly. Yes?
I mean, the process and read, it's like the loop yes or no, then you're gonna skip to the another one, yes or no, then you're gonna skip.
Yes, that's right. But what is the main difference? Option 3 and option 4. Yes?
I think option 3 is just for the overlay.
Overlap.
Yes.
Yes.
Relation.
Yes. I think 90% correct. Yes.
Third is a single relation, single attribute. Fourth is a single relation, multiple attributes.
No. I think he is almost correct. In this case, so I am the employee. Also, I am secretary and technician. Okay? If this one is overlap, yes, it's possible. Then, can you use this option? No. Because it doesn't allow overlap. Okay? So, in case of overlap, you can use only option 3. Right? However, if this one is a disjoint, you can use either this one or this one. However, in case of disjoint, this one is not very efficient or useful. Why? All the other. So in case of secretary, this is useless. Should be not. Right? Do you understand the difference between the option 3 and 4? That is the only difference. So, option 3 is for overlap case. This one is disjoint as well as overlap, but you go for disjoint case. So, we have 4 options. How can we select one of them when we convert ER model to relational model? Answer is, it depends on. As a user, it depends on what? Application and customer requirement. For example, if we have the overlap case or disjoint case, it should be either this one or this one. Also, when you analyze your application program, if your application program access entire employee, also for each employee type separately, you'd better select this one. Right? However, if your application program access only secretary, only technician, only engineer, not entire employee, okay, at the time, you'd better select option 2. Also, your application program consider the not special 90% of the application program was the database query. Access entire employee. Okay? Not specified. At the time, either option 3 and option 4. How can we differentiate option 3 and 4? In case the overlap, it's option 3. In case disjoint, the option 4 is good. Better than the other. That is the last step of converting mapping ER model to relational model. Let's see other example. It's a vehicle and car and truck. So as you can see, this is the super and subclasses relationship. So we can convert. We can select 4 different options. First option is vehicle relation, car relation, and truck relation. Second option is car and truck relation. Third option is one vehicle, then Yes or no. And last option is the vehicle type. Okay. So this is the job type. And typing speed, T grade. Last option. I think the option number is changed, but this is the last option based on the notation. And this is the flat. It's a yes or no, Boolean, right? It's the third option. For example, this one, how many entity can you find here? How many entity? So one entity for what? It's a person. It's in EER diagram. It's nothing but the one person entity, but it's specialized or generalized into the person. So how many super and subclasses relationship can you find? Many. 1, 2, 3, 4, 5. This is part of this 4, 5. So how many options can you select? For each super and subclasses, you can select different options. It depends on what application program, what data structure. So you can select different options. This is the one example. This is a third HOMO. So comparing this ER diagram and relational diagram, it's a map using options, several different options. Mark which options are selected for each super and subclass. For example, in person, employee, alumnus, student. For example, this one, what options are selected? First option. For this, which one? For this, which one? Why don't you mark? Okay? Which options are selected. Then, finally, you can understand the meaning of this one. When you see this one, you should be able to imagine this. Okay? So this is your homework. This is another example. And in third, the homework that includes this. Why don't you convert this sheep tracking database ER diagram into the relational model? It doesn't have extended ER concept over here, right? It's just the ER diagram. So why don't you convert this one into the relational schema diagram? As a user, only handwriting, it will take more time. If you draw the relational diagram, just handwriting only. So it's not two homework, it's one homework. One is just to explain what options are used in here to convert into this one. And another homework is the converter by following step by step. Step 1 through step, I think the 7th.
You choose one option here?
This time you don't need the option because it does not have super and subclasses relationship. So you can just follow the step 1 through 7. Okay? That's the end of the section 9. Then move to pretty much we complete the database designing part. Okay, so from the information we build conceptual design, that is the ER diagram or EER diagram. Then we can convert EER diagram into what? Relational model. So we have relational schema diagram. So from human to computer, machine to him, so 1, 2 steps further. We are getting close, but still computer does not know what he needs to build, right? Even though I provide a relational schema diagram, Okay, very nice relational schema diagram. He cannot create the database, right? To create the database, I need to order. Okay, I need to ask to him. I need to ask to the computer using what? Using what? How can you communicate with the computer?
PPL.
Using Siri, you can just say, or the kickback, so you can just say something. Right now, my daughter, she's a 7th grade. She almost hooked up by the kickback. So I asked something. But anyway, that's a little bit different story. But he does not know what he needs to create. I need to communicate with him. To do that, program language is the only way. Right? That's the reason to use the computer research. You learn the program language. Okay? Even though you have a very fancy, nice, brand new idea, rocket science idea, Nobel Prize work, if you cannot implement, if you cannot prove, that is just daydreaming. Okay? You should be able to create, build, implement such a thing. How can you do that? Using programming. In database, fortunately, database model provide the operation. Can you remember that? When we discuss about the database model, what is a model? It's a bunch of group of concepts, rule, structure. Also, in addition to the concept, it provides operation. Okay? So, to access, to build, to create the database, we need to something, the language. That is called the structured query language. However, can we use any program language to create the database? No. The object-oriented program, .NET, C#, or the Python, any other program, that program has their modeling. In other words, that each program has their data model, structured model. It's a different. Some of them are used object-oriented model, some of them are used different model. In database, we are using relational database model. So relational model, what is a relation? It's a set theory, right? So set theory has a lot of set operations. So we will utilize such a set operation to create the database, to access the data. That is called relational algebra. So relational algebra provide how to access the data. Okay? Or relational calculus is almost similar but a little bit different concept. We will discuss mainly about the relational algebra. Using that relational algebra is a fundamental. It's the data structure. Then you can create what? Database language, which is SQL. You know the SQL. Is there anybody who never heard about the SQL language? Most of the people know what is the SQL, but most of the people do not know what is the origin, fundamental of such a SQL. That is the relational algebra. First, we will discuss about such a relational algebra. That's the background of the SQL. So after you understand what is the relational algebra, it's not a big deal to learn how to use such a database language. Even you can implement new database language based on this one. The couple of years ago, it's last year. Last year, the advanced database design course actually implement the new relational database management system. After we learn this one, it's posted on the my Google website, so I will show sometimes later. To do that, you definitely know the background, fundamental of the relational algebra. That relational DBM is actually very simple. It doesn't support any join operation, complicated operation. It has only one key, primary key, and it is only the single, like the select, column name from table. And the condition is the equality or inequality only. Also, it doesn't support the block-based, the internal schema. You learned what is the internal schema. At that time, you should know. You should design the internal schema as well. Okay, so that is the next step. I'd like to offer the such an advanced topic class near soon, but not this semester. So relational algebra is the operation used in the set theory. Then we adapt the idea of the set operation to the relational model. Okay, so to access the relational algebra is the basic operation of the relational model. Then relational algebra expression is just like the English or any the language. So we have the word by word. By combining word using the grammar or the certain rule, it can be sentence. Okay? So relational expression is kind of sentence. It's a sequence of relational operation. When you access the data in relational database model, it's not that simple. There are very, very complicated way. Why? Is that the benefit of the relational RDB, relational database? No. The main purpose of the main benefit, advantage of the relational model RDB is we consider data as a relation to remove the redundant information. Student, what else? Instructor, course. Then how do you connect for each relation? Using foreign key. Okay? So data are not in one table. It's separated. Right? That's what we did so far. So to access data, sometimes you need to access data in the student table only. That's simple. However, sometimes you need to access the data student and course, student and instructor. Sometimes a 4 table, 5 relation, 10 table. So many different ways. Okay? So to show such a complicated way, we need to combine many operations. That is called the relational algebra expression. Okay, so we will use the same database, the company database, also including the foreign key and primary key. I believe that you still remember that one. The first one is the selection. So selection is, what is the definition of the relation? Definition. What is the definition of a relation? What is a table? It's a group of data. Okay? Relation is nothing but a group of data. Like the set. What is a set? It's a group of elements. So, I'd like to access data by data. I don't want to access the whole the data in one table. Certain table, certain data in one relation, one table. So, relational database model provide the first operation that is called selection. The symbol is sigma, like this. Okay? Then, employ relation name with condition. For example, the department number is 4. Condition is subscript. And in parentheses, there is a relation. Okay, what does that mean? Employee who are in department number 4. What does that mean? Employee whose salary is bigger than 30K. Very simple. That is the way. So what is the relation? It's like this one. Employee table and the 111, 112 social security number and salary. So not all employee, but the employee that satisfied with such a condition will be returned. Okay? That is the first operation. Okay? That makes sense. We try to access the data with a certain condition. So this selection provides the operation to access the data with certain condition. At the time, condition is subscript and the relation name is in parentheses. One more important thing. This is kind of function. What is a function, by the way? Have you ever learned about function? Yes, in your 3rd grade or 4th grade in your elementary school. When I learned the function first time, my teacher showed this one. It's a kind of black box. We don't know what happened, but if I put the number 2, it will be 4. Number 4 is 8, something like that. I can guess this is times 2 function. Input and output. Function, it has the input and output and apply the same operation to all the input. That is the reason function in Chinese is like the box, right? If you write the function in Chinese, it's I don't know exactly how to write. It's kind of the black box, right? Don't agree? No? I don't know. Anyway, so it's kind of the box, black box. So this is kind of the function. Input and output is what? What is the output? Employees who works for department number 4.